Hi, it's Bill Clinton again. This is part 2 of a 3D surface milling in RhinoCAM. We assume that you've installed all the tools and you've got all your stock, box stock made by now. Okay, so we are going to assign some tools and some tool paths to this 3D surface. The first thing we'll do is go to the three-axis horizontal roughing toolpath, and the tab that comes up is the machining features and regions. Let's select drive region, containment region, one click, and then we'll right click anywhere in that field, and we have selected that as our drive region. That means inside that rectangle is where our tool will cut, and it won't go outside of that. Speaking of tools, we need to pick a tool, and we're going to use this one, 1/2-inch ball mill, round nose ball mill. I'm going to show you this. You can see it's giving you the size of the bit itself. I've already assigned feeds and speeds for foam for this bit. There's the spindle speed and then feed rates in inches per minute. We don't have to do anything to that. I just thought I'd show you. Let's double check to make sure the feeds and speeds are there. They are. I'm going to go to the clearance plane. The clearance plane is this transparent red plane that is the limit by which below which the tool can't go when it's making moves between different cuts. So it's just an insurance policy, so the bit won't cut into the material that you're trying to mill in a bad way. So let's set that for stock max Z plus the distance. So the stock is there, and we're going to go 1/4 of an inch above that. This next tab, cut parameters. Most of these things are defaults. We have to change basically one thing for this cut. Stock is the amount of material you can see right there that is left for a finished tool path to clean up. So we're going to leave that set at 25 thousandths. And down here at the step over control, we're going to set that for 75%, because that is the distance, percentage diameter that the tool will step over each time. We're going to go to cut levels, and we're going to change that to 75 too. That means that 75% of the diameter of the bit is how far each time it steps down. And that has to happen because it can't mill this surface all at once. It has to do it in layers. Engage retract is another default that you don't have to change, 10 degrees. And advanced cut parameters, there aren't on this particular tool path, so we're going to just let that go. And right at the bottom, generate that tool path. So you can see we've got a tool path here. We're going to choose the tool path and go up to the Simulate tab and play this. That's happened pretty quickly. You can see, we'll toggle off the toolpath visibility, and we can toggle off various things here at the bottom. You can see it's a pretty rough toolpath. That is what we want for now, and we're just about ready to do a finished toolpath.